Okay, so yesterday at the end of class we finished example 4. You should have the information in your notes, right? Now, in order to graph this, hopefully you have someplace you can put a graph. I have the whole thing since mine doesn't have the information from yesterday. But I'm going to get myself a set of axes drawn here. And I'm just going to use lots of space since I have lots of space. Obviously, you don't have to have this much space. Okay, let's start with, what do we know about the center?
It is -2, 5.
-2, 5. And I know that just by looking at my equation, right? Even though I don't have the information from yesterday written down, it is -2, 5. So maybe I should have drawn my graph a little differently.
It'll be fine. It's fine.
I'll make it work. So I'm going to go left 2, up 5, and that is my center. Okay? Now, this is where I'm like, oof, okay, so really if you are early in your early stages, you're going to need lots of room to go up, it looks like. This is a disadvantage with me not having it graphed already in my notes. I'm doing this on the fly, so yeah, you're going to need room to go up, I will say that. Now, there's my center, yes?
Yes.
Okay. What is my A value?
3.
A is 3, yes?
Yeah, that's what I
And that A value of 3, it counts out from the center. Is it going to count out left and right or up and down? How do I know left and right?
That's under X.
Okay.
Left column.
Right there, we know our A is 3. It's under the X value. Which way do X's go? X's go left and right. So we're going to count out 3 from the center, left and right. So I'm going to go 1, 2, 3 to the right, and 1, 2, 3 to the left. Now, those are my A values, right?
Yes.
What else does an A value denote? Vocabulary word here.
Asymptotes.
No.
Transverse axis.
I was
Yeah.
getting there.
Okay. Plus or minus A
The vertices.
are your vertices. So these points right here, when we just count left and right, are my vertices. Okay. So now does that match up with what we already had written from yesterday? We had a vertice at -5, 5 and a vertice at 1, 5, right? So you could have also applied your vertices that way. Okay, what's B?
7.
Okay, B is 7. And which way do I count 7? Up and down, because it is under the Y, and Y's go up and down. Yes?
Yes.
So we're going to count from our center up and down 7. Down 7 puts me at -2. This is where it gets a little dicey because I should have redrawn my graph. Up 7 takes me into the word hyperbola. And officially it should be at 12, correct? Those are my B values. And keep in mind, those are my B values. They don't have another name like vertices. They're just my B values. Okay. Now, what do I use my A and B values to do?
Make a box.
Make a box.
For the
dotted box.
asymptotes.
A dotted box, not like a
Yeah. So, horizontal and vertical lines through the A's and B's. Should be a kind of taller box, right?
One more.
Taller than it is wider. Because really this box should be 14 tall, but only 6 wide.
Mine's
Through the box, what do we do?
The asymptotes.
Okay, the asymptotes are diagonal through the box. when you draw these asymptotes, one asymptote needs to touch 3 places: the center and the 2 corners it passes through. So I know for me that means I draw my asymptotes in 2 halves. Okay. Now, important question. We need to draw these hyperbolas in. How do I draw my hyperbolas in? So which way are these hyperbolas going?
Sideways.
So what?
Sideways. X, like the X way.
Okay.
You're gonna face the X like that.
Okay. So they're facing out from each other?
Yeah.
How do I know they're facing out from each other?
Because they don't have a solve problem.
Okay. X was my first variable. It was my positive variable. And so X means my hyperbolas would be on the x-axis or equivalent to being on the x-axis. So this is, you're using your A values. These are going to be very wide parabolas. Whereas if my parabolas, or hyperbolas, if my hyperbolas went the other way, they'd be more narrow. Okay? Now, it didn't say to. Well, it didn't even say to graph it. I didn't put my foci in. Could we put the foci in? We could. Actually, we know the foci, don't we?
Yeah,
Yeah.
so okay.
Although we have to do that decimal work there. But your foci are going to be where? Out here somewhere? Okay. I don't know exactly where because I haven't done the math, so it's whatever. What is the square root of 58?
That's a good question.
7 something?
Something.
7.4.
6 more.
7.6. So a -2 plus 7.6 is going to be at 5.6. And -2 minus 7.6 is going to be at -9.6. So farther out than what I have them, but. Okay. Good review of graphing, I hope? Okay, I feel like that's something we need because when you get your review worksheet on Friday, yeah, you're going to have to be able to graph. Okay? And my point is, everything was pretty much here. I just had to interpret it. Okay, here we go. We're only doing A. So you can work all into B and C that you want. Graph the following hyperbolas, stating their vertices, foci, asymptotes, and eccentricity. Okay. Well, it doesn't officially say prove it's hyperbola, but essentially that's what we need to do, is we need to prove that this is hyperbola. Do you remember how to do this? Other than just mathematically.
Well, you gotta make the recipe equal to 1.
Okay.
The easiest way to do that is probably divide by 18.
No, you have to
Not this one.
first. You have to do.
Oh, my finger slipped.
Okay. So we need to group like pieces here, don't we?
Yeah.
We want our x's together. We want our y's together. And anything that is not x or y goes to the
Right side.
right.
And no variables in front of the one.
Okay.
I was
That'll be my next step. Now, like I did last time, my brain says I'm going to put x's first and then y's first. However, I'm going to change that a little bit here. My brain here says to put y's first because y squared is positive and x squared is negative. So go with the flow on a hyperbola, put the positive one first. Okay? So, let's see. We have y squared plus 6y. I'm going to go ahead and start leaving my gap now, even though I'll probably do another step before I need it. Then I'm going to have minus 3x squared plus 6x. I'm going to leave a gap. I have equals 18, and I don't have anybody I have to move over, do I? It was already over there. So I grouped the variables together. Now my job is to get set up for completing the square. I say x squared plus bx because that's how we learn it, but that applies to x's and y's. Now, in this case, y squared plus 6y is good to go. I'm just going to recopy it down. I'm going to leave my gap. X's, not really good to go.
Factor of 3. Negative 3.
Okay, and here's the deal. Whatever, even if that was not a 3, it was just a 1, on the second one, you're going to need to factor out the negative. Okay, so if it was just a minus x squared, we'd still need to factor out a minus to make this happen, right? In this case, we're going to factor out a minus 3. And when I factor out minus 3, what's that leave me with?
X squared plus 2x.
X squared minus 2x, because I'm factoring out a negative there. Okay, because if you don't factor out a negative, you have a negative x squared in our completing the square, which, yuck. Okay. Complete the square. What about our y's? B is 6. So 6 divided by 2, quantity squared, is going to be 9. Add 9 on the left. Add 9 on the right. And it's not that you have to write down what you're doing off to the side there. I just find it helpful sometimes. For our x's, b is negative 2. Negative 2 divided by 2, and then square it makes it a plus 1. Add 1 on the left. We're going to add 1 times negative 3 on the right.
Minus 3.
So yes, really you are minusing 3 on the right. And I don't care if you guys go ahead and write that. I just don't write that as the teacher because I want someone to go back and look at it and think, oh yeah, now I see it. Okay, the whole point of completing the square is now we are ready to factor into a perfect square. Y squared plus 6y plus 9. Square root of y squared is y. Square root of 9, 3. Or in other words, 3 times 3 is 9, and 3 plus 3 is 6. Keep the minus 3 here. Factor your x's. Square root of x squared is x. Square root of 1 is 1, and that is a minus 1. Equals.
18 plus 9.
I can go with 24.
24. Good job, Kylie. Thank you, Sophie.
Okay, now, Connor, I have to disagree with your very first step you said at the beginning of class.
Now we got to divide by 24.
Yeah, he wanted to divide by 18 earlier. That wasn't, it was too early.
It was too early. I don't know what was going
So now
It's too early.
we're going to divide, but we're going to divide by 24 to make this a 1. Okay, with that in mind, final form. Y plus 3 squared over 24 minus, what about our x's?
8. X minus 1 over 8.
X minus 1 squared
Yeah.
over 8 equals 1. Okay. There is our proof that this is a hyperbola. We were able to get it in hyperbola form. Okay. Vertices, foci, asymptotes, eccentricity. Well, in order to do all of that, we need some ABCs, HK. Just helps if we write it. To me, it helps if I write it all down. So, H is
No, negative 2. Negative 1.
1. It's just
1.
one.
Just
Oh,
one.
negative
Just
1.
Just 1.
Sorry.
Whew, that was rough.
K
I
equals
still
negative
put-
3.
Actually, I put 2 in there.
Are we good that h is 1?
Yes.
Yes.
It comes from the x parentheses, so you can't go first or second. It comes from the x parentheses. K is?
Negative 3.
Okay.
What happens when you say
A.
I don't have bangs, I'm just blonde.
Mario getting himself in trouble here.
Yes.
Okay. A.
The square root of 24.
Yes.
Okay. Square root of 24, not because it's larger, because it's under the first one, the positive
Yeah.
one, right? Okay. And what is the square root of 24 simplified to?
That's what I was.
2 to 6.
2
What?
square root of 6, right?
Hooray.
Because
Oh,
24
4 times 6,
is
okay.
4 times 6.
Yep.
Go join my Algebra 2 class. They're doing this right now.
I'm good.
And in fact, geometry is simplifying perfect squares too with what they're doing.
I'll ask Patty.
Because there you go. You know?
Over my dead body will I ever.
Although they were a little, I don't know. I worked on it at home last night. It was a little rough at first. So I rarely help with geometry in my household, but I did last night. So. Okay, B.
I used to sit at the table and cry because my dad would come.
Okay. Starts off as square root of 8.
2 square root of 4. 2 square root of 2.
2 square root of 2. Mario's wearing his tutu again. Okay.
I'm gonna bring it to Mario's
C.
Pink one?
24
C.
plus 8, which is 20, no,
32.
32.
Okay, so C squared is A squared plus B squared.
Should be like 2 square root of 8.
They said 24 plus 8, which is 32. So this is 4 square root of 2 because the
16.
best thing is 16. Go big or go home is what I told my Algebra 2 kids the other day. 32 divides by 16, so 4 square root of 2. Okay, we have our ABCs, we have our HK. Finding all the rest of this stuff should be
A breeze.
piece of cake at this point. So let's see, what do we need? Okay, vertices. What's my formula for vertices?
Oh, I gotta flip it over. It's a right column.
I was wondering if anyone was going to say that. We never talked, did we?
HK plus minus.
So this is a right column because y is the first and positive one. And so this was what?
H, comma K plus minus A.
Okay. H comma K plus or minus A, which is going to be,
Why do they all have to be square roots? What the heck is that? I just know.
You gotta do mathematics.
okay, if I got it right, 1 comma negative 3 plus or minus 2 square root of 6?
Precisely.
Can we just leave it since there's a square root of 6?
Yes.
That was precisely.
Yay.
Now, and keep in mind, I mean, if you left it square root of 24, that would be equivalent too. Okay, that was vertices.
Focuses.
Foci, formula for foci is going to be H comma K plus or minus C. So take your vertices and just switch out A for C. So 1 comma negative 3 plus or minus
4 square root.
4 square root of 2.
I did it.
What else? Asymptotes?
Plus or minus B over, no, A over B. And then in parentheses, X minus H. Plus K.
And make sure you say y equals at the front because these are asymptotes, which asymptotes are
Wait.
equations, right? Whenever you guys gave me an asymptote in algebra, I always said, okay, don't just tell me the number. It's x equals or y equals depending on the scenario. Okay, here's your formula. Fill it in. Y equals plus or minus. Now, as I look at A over B, I guess it doesn't matter. And say, you could if you wanted to, it might be a little bit easier math to just say square root of 24 over square root of 8. But you're going to be able to reduce that the same as you're going to be able to reduce 2 square root of 6 over 2 square root of 2. So it's not going to matter what you do here. I'll go ahead and say 2 square root of 6 over 2 square root of 2. If you did the other one, that's fine. X minus 1 plus k, so I'm going to say minus 3. If we clean up what is essentially the slope, plus or minus, in this version the 2's cancel, what's square root of 6 divided by square root of 2? Square root of 3. Now, this would not be, well, you could graph this. We could also put it in point slope. For the benefit of what we're doing here, I'm just going to leave it as is. And I'd have to look at the answer key to make sure that's how I left them in the answer key. And one last piece. Okay, eccentricity, what's that formula?
Let's just
C
see.
equals C over A.
Okay. C over A. I was just debating, do I want to do 4 square root of 2 over 2 square root of 6, or what I think I might do,
Square root of it.
just for the beginning, it's going to just take me a little quicker. So square root of 32 over square root of 24. Does that make sense there? Because then both numbers are under square roots, so you can divide. You can divide this. They're both under square roots or both out of square roots. You just can't mix and match. So 32 over 24 reduces to
4 over 3.
divide them both by 8. And you have square root of 4 over square root of 3. Now, you could possibly leave this answer as square root of 4/3, which is what this version would be. Or if we rationalize, how do we rationalize? Multiply by, oh wait, I don't want to leave that square root of 4/3. What am I thinking? Call me out on it. Why do I not want to leave it as square root of 4/3?
You can't have, you're not supposed to have a fraction.
Well, irrelevant to the fraction. What about this numerator? Square root of 4 is 2. So this could actually be 2 over the square root of 3. The book sometimes leaves them unrationalized, which is, so this is what I was saying, that you could possibly say 2 over square root of 3 as an answer. However, if we're going to rationalize, we're going to multiply by, how do I make that square root of 3 a perfect square? Multiply by itself. And then we have 2 square root of 3 over 3.
Okay.
Okay. I took up my entire screen there.
That was.
I took out the entire page. Just
Hey, I told you.
after nothing.
Okay,
Did you actually?
you have homework to work on, yes?
Yes.
Yes.
Use this time
I did it.
to get working on homework.
Can I grab my book from my locker so I can just use that instead of.
It is on page 592. Numbers 2, 4, 6, 7 through 10, 24 to 42 evens, 49 and 50, 49
It says omit 34.
and 50. And then at the very end it says omit 34. Omit. New vocabulary word for you.
I don't know what it means, but I've heard it before.
You're going to omit something. What are we going to do with
It
34?
stands for something.
Not
doesn't it?
Slang, just the condensed version of oven
Leave
mitt.
out or exclude.
There you go. So, would it be better if I said skip? You're going to skip 34.
It does really make a difference.
It's hot. Let her have some on this.